So, Armin, from your experience, what are the most important challenges in NLP that need to be solved?
One of the biggest challenges is understanding and maintaining a context throughout a conversation. When you are talking to someone, it typically lasts for more than a single utterance and response. And as the conversation proceeds, you start building a mental model of what is being discussed, which provides further context to correctly interpret what is said next. We use mental shortcuts. Psychologists call this heuristic bias. I don't think we have cracked this problem yet, and it severely limits the capabilities of NLP systems today. And it's not only applicable to conversations. Processing large chunks of text, like an article or report, becomes very hard if you don't have a mechanism to extract and use the facts and relationships being presented. What the system is lacking is experience, a general knowledge of the world. This is an active area of research, though, so I expect to see a lot of progress in the future.
That's very promising. What other NLP problems are AI engineers and researchers actively working on?
Arpan, I love this question. It reminds me of the advances in deep learning, a subset of machine learning, those that are realized and the shape of things to come. Let me take a step back. Pedro Domingos, in his book, The Master Algorithm, which I highly recommend everyone to read, identifies three major AI caliber categories. Today, we have artificial narrow intelligence, ANI, sometimes referred to as weak AI. Artificial narrow intelligence is AI that specializes in one area. ANI can beat Jeopardy world champion. Ask it to figure out a better way to store data on a hard drive, and it'll look at you blankly. Second is artificial general intelligence, AGI, sometimes referred to as strong AI or human-level AI. Artificial general intelligence refers to a computer that is as smart as a human across the board, a machine that can perform any intellectual task that a human being can. Let me give you an example of baby steps that Carnegie Mellon University has taken towards AGI. When you walk into the CMU main lobby, you are greeted by a robot. Not a humanoid shape, but it has track wheels and a screen that is supported by a stand. I asked the robot to guide me to John's office. The robot has facial recognition APIs, and since I have registered, it says, "Hello, Armin, gladly. Please follow me." As I walk down the hallway, the screen tells me that in 20 feet we turn left, in 15 feet we turn right, and the coloring of the stand is turning greener as we approach John's office. Just as it passes by the elevator, somebody kicks a chair in front of the robot. The machine sees it, stops, and goes around it. So do I. Once it reaches John's office, John asks the robot two very difficult questions for any machine. What happened at the elevator? Why were you late? The robot has an awareness of its surrounding, not of itself, but of its surrounding. And the third category is artificial superintelligence. Oxford philosopher and leading AI thinker Nick Bostrom defines superintelligence as an intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. Artificial superintelligence ranges from a computer that's just a little smarter than a human to one that's trillions of times smarter, across the board. Today, if I ask the most advanced deep learning system a question such as, "Watson, tell me about quantum computing," it will likely say, "Armin, I do not know about quantum computing. Perhaps you can teach me." And so I will have the system ingest relevant documents and it will become part of its corpus. But it is an entirely different thing for the machine to say, "Armin, I know that I don't know about quantum computing. Perhaps you can teach me. With ASI, the system is becoming aware of itself.
It sounds like artificial superintelligence is what most people expect out of autonomous systems, but we are clearly a few hurdles away. How are researchers solving these hard challenges, and how does deep learning apply to NLP?
NLP has its roots in computational linguistics, and researchers began tackling the problem using rule-based systems. But due to the inherent complexity and lack of structure in natural language, deep learning approaches are being adopted to solve problems such as semantic analysis and disambiguation. A number of associated challenges need to be addressed. For instance, how do you transform text into a representation suitable for learning? How do you interpret the output of such a system? I think the secret sauce is in the algorithms. Our developers are now experimenting with LSTM, long short-term memory, a modern approach to neural nets to tackle exactly such problems. Image captioning and visual question answering are also very hot topics of research these days, which combine both modalities, image and text. Deep learning approaches use a common underlying vector representation for such problems and are being applied to them with great success. Beyond NLP, these systems may become precursors to more general purpose AI systems.